Hey y'all, it's me, Miss B. Today we're talking about graphing quadratic equations to solve. Alright, so finding the zeros on the graph. The solutions to quadratic functions are where functions touch the x-axis. We can also call them zeros. Alright, the zeros of a function are the values for x for which the function of x equals 0. Okay, so wherever f of x equals 0, is where the solutions are. Okay, so here are some other names, and this is going to be important for directions. It might refer to it as something else. So in the future, if you have like a test or something like that, it might say find the zeros, or it might say find the roots, or it might say find the x-intercepts. They all are the same thing on the graph. And so here over to the right here, we have a graph. And so these points where they touch the x-axis, those are x-intercepts. They're also where x equals 0. So that's why they're called zeros. And then roots is just a funny name. I'm honestly not sure where it comes from, but it is another synonym for solution. So there are actually 4 names: solution, zero, root, and x-intercept. Okay, so we can look at these graphs here to list the solutions. So here it says x squared minus 1 equals 0. And it's been graphed for us. And so our solutions are these points which cross the x-axis. Okay, so I'm actually going to highlight that a little bit differently than I did. It's those points where they cross the x-axis. So where those intersect with the x-axis are the solutions. So it's going to be x equals -1 and +1. Okay, so you can write your answers like that. You can also write it like that if you want to. Okay, for this one here, where it crosses or touches the x-axis is only one place at 0, so x is equal to 0. Then for this last one, it has y is equal to x squared plus 1. And I have no solution because it doesn't ever cross that x-axis. Okay? So no solution. Okay. All right, so those are also our 3 types of solutions. We can have 2, 0, or no solutions. Okay, so looking here, it says, from the time Mark Twain wrote The Celebrated Jumping Frog of Calaveras County in 1865, frog jumping competitions have been growing in popularity. The graph shows a function modeling the height of one frog's jump here, where the x is the distance in feet from the jump start. And it says, how far did the frog jump? Okay, so let's count it out. So this is 2, 4, 6, 8, 10, 12, 14, 16. So that right there is 17. So the frog jumped 17 feet. Okay, so that point right there where it crosses the x-axis is really important because it shows us the end position. And then for how high it jumped, that is right here. We're actually not sure because it doesn't have a label on the graph, but I'm guessing 1, 2, 3, 4, 5, 6. It jumped about 6 feet high. Okay, so that's what that peak is there. Okay, moving on. Sometimes we can use Desmos to graph our quadratic equations to find solutions. Okay, so unless it tells you to graph using Desmos, you should not be graphing using Desmos. You should be graphing by hand unless told otherwise. So there's a fancy little app you can buy on your phone or something like that. And so we are going to find those on here. So I'm going to go to my Desmos app here. And our function was x squared plus 1. So I'm going to type in x squared plus 1. Okay, so as you can see, here is our, I can't really highlight, but here's our x-axis. I'll just put that. So let's just plot y equals 0. And let's actually change the color to something like green, since that's the color we used before. Okay, so that green is the y-axis, and the red and the green don't overlap. They don't touch, so there is no solution there. Okay, so for this one, there is no solution. Okay. This next one, x squared plus 6x plus 8. Let's look at that. I'm going to close that here. Okay, so here you can see that it does overlap, and if you click on these points, it'll tell you what those points are. So the x is what we want. So x is -4 and x is 2 are where those, x is -4 and x is -2 is where those points intersect with the axis. So x is equal to -4 and -2. So we don't even have to count because it tells us. All right, this next one here, I don't have it equal to 0, and I need it to be equal to 0, so I'm going to add 5 to both sides, just like we did last time. And so we have x squared minus x plus 2 equals 0. I'm going to go ahead and graph that on Desmos. So there's that. All right, again, it doesn't intersect with the x-axis, so there is no solution. Then finally, this last one here. Again, I need to subtract 15 from both sides to get 0 on one side. So I have negative x squared minus 6x minus 25 equals 0. Since I'm equal to 0, I can just plot that, or I can graph this on Desmos. There's that. Okay, it doesn't show up because I have to zoom out to see that graph. Okay, and as you can see, it does not intersect. It's shifted too far down. So again, we have no solution. Okay, sometimes we want to graph by hand. So this is, I'm going to rewrite this as x squared plus 0x plus 1. Because our negative b over 2a to find our x value would give us negative 0 over 2 times 1, which is just 0. Okay? So then our y value is just, our y-intercept is just 1. So there's that. We do have a slope of 1, so we want to go up 1 over 1 to get that point. Reflect it over that, let me rewrite this here. Reflect it over the axis of symmetry, and there's our parabola. All right, as you can see, there's no intersection with the y-axis or the x-axis, so there's no solution. All right, let's do this next one. All right, so to find my vertex, I do x equals negative b over 2a. B is -4. A is 1. So we simplify and get positive 4 over 2, or 2. Then for y, we plug in. So we have 2 squared minus 4 times 2 plus 4. So we get 4 minus 8 plus 4, and we get 0. So 2, 0 is my vertex. And my axis of symmetry goes through that point. My y-intercept is 0, 4. So I'm going to go ahead and plot that point. Then reflect it over the axis of symmetry and graph that line. So my solution to this one is where it touches this axis here. So this point, 2, 0, means that my intercept is x equals 2. All right. I believe that's it. That's all for today, folks.